welcome to our first person coming through. We've got some other people coming through. And as you will see, we've got Heather Toswell. Welcome, Heather Toswell. Thank you for joining tonight. We're going to keep everyone muted right now until throughout the entire time, actually. So, and we're excited to be here. This is our third and final Love Your Lake Zoom seminar for this year. So that's exciting. And Scott, you're madly admitting people. Here we go. Welcome, people. Welcome. Welcome, everybody. Let's just see. So we got some more people there. Do you need some help there, Scott, or are you okay? You okay? Oh, you're muted, but.
There's no one in the waiting room right now.
Oh, there's no one in the waiting room. Okay, perfect. So everyone is in. Perfect. You're just okay. So then we'll get started then, because it's 7:30. Welcome, 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 everybody. And Scott will admit more people as they come through. Thank you for joining us on this Tuesday night in May for our third and final Love Your Lake series, a Zoom series for this current year. And we hope to again bring some more for you again next year. On behalf of the LKO members, the LKO board members, we wanted to welcome you and to remember how the evening works, that this will be recorded so that people can watch it later on in the future if they wish to, on our LKO YouTube channel. Go check it out and subscribe so you too can watch any one of those videos that have happened in the past and learn, because we all are learning from all these great speakers that we've been having. We're going to be using the chat function today. Scott and Jan will help us with the chat functions and the questions that will come through during the Q&A session. So feel free to do, as we're going along, use that chat function. We will keep ourselves muted. When our speaker, Andy Gordon, does start his presentation, we'll ask everyone to mute themselves and to turn off their videos so that we can all watch his presentation more effectively in using this lovely intranet as we're doing it, because it'll be much easier to see it all if we're all muted and our videos are off. But I wanted to just introduce the people behind it all, because it's more than one person that makes this happen. There's Jan, there's Wendy, there's Gary, there's Scott, there's another Scott, there's a Bob, there's a Kathy, there's a Marilyn, a Tanya, Wendy, and Jan. Did I forget Jan? I think I've got everybody there.
Got us all.
Our LKO board, all our volunteers. We're happy to bring these seminars to you because we love learning about our lake, and we love learning how to protect and bring awareness to it. So we're really happy to bring these speakers to you so that they're informative and it brings us together as a community. So without further ado, I'm going to introduce you to Jan Drew, your LKO president, to introduce our speaker for tonight. Over to you, Jan.
Okay. Good evening, everybody. I'd like to introduce and welcome our speaker tonight, Andy Gordon. Andy holds a Bachelor of Science in Forestry from the University of New Brunswick and a PhD from the University of Alaska in ecosystem ecology. He has a particular interest in the interaction of aquatic and terrestrial ecosystems in both forested and agricultural areas. He taught at the university, and did research at the University of Guelph for 32 years. He's recently relocated to the Haliburton Highlands. However, he and his family have been associated with the Highlands, Dorset, and Algonquin Park since the 1940s. So he certainly knows the area very well and intimately. He is dedicated to finding logical solutions to resource management and societal problems, and welcomes input from all sectors. So I would like to welcome Andy, and we will turn the floor over to him at this point. Welcome, Andy.
Great, thank you very much. This is what I look like before I start to share my screen here. And everybody see that okay?
Not yet.
Okay.
Yes. Yes.
Perfect.
Perfect.
Okay, good to go.
Yes.
Okay, well, thanks for that great introduction. I can't see anybody else on screen, so please tell me if my audio is okay. And as I've just had a 15-minute conversation with the organizers, I'm very cognizant about not going over time here. So just yank me when you've heard enough. So there was a typo in the title. So I don't know whose fault that was, doesn't matter, but I changed it around. Anyway, today I'll be talking about the aquatic terrestrial interface, something I've been interested in for an awful long time because it's very ecologically important. I'm currently the director of ULinks, a nonprofit in Haliburton County that you may have heard of. So if I don't get to your question, please feel free to direct it to me at director@ulinks.ca. The University of Guelph stopped paying me after I retired, but they ironically let me hold on to my email address. So that's available for your use as well too. Okay, so we have a technical problem. I can't seem to advance the slides here now. Oh, there we go. Everybody see slide 2?
You bet.
Okay, so I come to this interest in an honest fashion. This is a picture taken in 1939. My grandfather, who had a cottage down on Balsam Lake, that's my dad, the smaller guy. So my grandfather taught my dad to fish, and he taught my brother and myself to fish. And because my father was an ecologist with M&R for many, many years, he often would be talking about the ecological importance of the lakeside terrestrial habitat. So that's where that comes from. I was also very fortunate when I was an undergraduate student at the University of New Brunswick to do my senior thesis on this little stream, Narrows Mountain Brook, which was a gauge stream. It was just fascinating and just continued to excite me about how terrestrial and aquatic systems interact. Once I moved to the University of Guelph, after a few years, I was asked by the Ontario government to help them design a long-term ecological research program, which I did with a colleague, Bill Cole, in 1994. And unfortunately, the way politics works, that so-called long-term ecological program was only around as long as the NDP government was. And as soon as Mike Harris's Conservatives came in, it was axed. However, as part of that program, one of the very important areas of examination for us was in the examination of how terrestrial and aquatic systems interacted. So at the University of Guelph, I largely worked on systems like these, what we refer to as agroforestry, or more simply farming with trees. You've probably all seen driving around in Southern Ontario, the one tree out in the middle of the agricultural field where all the cows are congregated under it. So the concept of agroforestry is just to spread the trees around a little bit more. So we worked on these systems, and we worked on combining crops and trees. And I probably would have been a pretty disappointed scholar if in fact agroforestry had not embraced this next field, which is known as integrated riparian management systems, which is a fancy term for talking about putting trees back onto agricultural streams. And if you've driven around Southern Ontario in the 1970s, this would have been a very common sight. Most cattle were allowed access to streams for water. And in doing so, they often defecated in the stream, destroyed the integrity of the stream bottom and the banks, as you can see. And it generally was not a very public picture. So this is sort of where we're going to start. And I'm going to start telling you about a study at Washington Creek in southwestern Ontario, fairly close to Guelph. We'll move up into central Ontario in Algonquin Park and talk about some work we did at Scott Lake. Then on to a boreal situation in the Esker Lakes research area north of Cochrane. And we'll finally end up with a couple of studies that were kind of neat up in the Northwest Territories. So I think you can all agree that the picture in the bottom right is a better way to view an agricultural stream than the one in the top left. And it really wasn't until the Walkerton tragedy, which occurred in May 2000, under the Mike Harris government, that the importance of surface water quality, especially in Southern Ontario, came to the forefront. And despite a lot of, excuse me, a lot of political challenges to date, including the current government, which has been attempting to decrease the importance and role of conservation authorities. Many of the conservation authorities have developed just excellent educational programs and work with the farming community, basically to show them how important that planting of trees along agricultural drainage ditches and existing streams is. So we were lucky to get in on the ground floor with some of the research. This is a picture of Washington Creek taken the day we started to work on it. It was highly degraded. It was heavily sedimented. As you can see, there's some cows in the background. They had access to the stream. There wasn't a piece of woody vegetation on its entire length. It's a first order stream that flows into the Nith River and hence into the Grand and into Lake Erie. There was no fish in it, no bugs in it. The water temperatures exceeded 20 degrees C in the summertime. So as a result of that, it is virtually impossible to introduce any fish populations into it, including ones that like cold water, like trout. So we took a approximately 3 kilometer stretch of this stream, and we planted it up with fast growing hybrid poplar trees. They're known as whips when they're in this stage. These trees are a year old, and these areas, riparian areas, are very, very fertile in their own right, but even more fertile when they're next to agricultural fields because of the excessive amount of nitrogen fertilizers that are applied. In fact, in this particular picture, you can see that the field, the height of the field is about almost a meter below the original height of the bank, of the river bank. And so all of that material is in the river and is now at the bottom of Lake Erie. So this is what it looked like a couple of days after planting. This is what it looked like in 4 years after planting. As I said, the trees are very fast growing, partly due to the genetics of them and partly due to the very rich, fertile situation in which they found themselves. So this was, like I said, about 4 years after planting. And at this point, these trees, hybrid poplar, are not that much valuable. It's very difficult to sell a system like this to a farmer on the basis of ecological altruism, if you will. Farmers have a bottom line and they want to see profit from everything they do. And so we underplanted this scenario with ash, oak, and walnut trees. And eventually the private landowners on whose property we planted will benefit from the harvesting of those trees. This is what it looked like about 20 years after planting. Hybrid poplar are generally not long-lived, and so you can see that some of the trees actually started to die and fall into the stream, which was an ecologically important thing for them to do because they broke up stream currents and started to contribute a little bit of woody debris to the stream. We did electrofishing every 2 years from the time we planted right up until about 2015. And in 2005, if you'd been out there in the spring, you could have walked across the stream on the backs of the brook trout that were up there spawning. And I have to say, it's not simply because we planted up 2 kilometers of stream bank. It's because of better farming practices upstream that the Ontario government was encouraging, and it was because of better fisheries management and water quality management in Lake Erie. So, but that was a success story. And we found in our electrofishing, we even found once occurrence of red-sided dace, which is a rare and endangered species in Ontario. I would have to check the current status of it, but at the time we found it, it was rare and endangered. So just a little bit of simple data here. So on the y-axis, we have percentage of open sky max. This is just riparian, the effect of riparian plantings on solar radiation that is incident on the center of the stream. So if you're standing out in an agricultural field, you'd be receiving 100% solar radiation. So this was 4 years after planting. This was 5 years after planting, and you see the trees are still fairly young. The crowns are just starting to touch over the middle of the stream. But by about 16 years, the crowns have touched, closed over the stream, and have basically started to block the solar radiation that's incident on the stream, with a subsequent result that stream temperatures started to plummet, mainly because this was a flow-slowing stream with lots of meanders in it. So, of course, as the trees got bigger, they started to do what trees do in the fall time, which is to get rid of their leaves. This is a process which ecologists call litter fall. It is absolutely by far the most boring ecological process known to humankind, but it's incredibly important. And as the leaves fall out of trees, of course, they contain a certain amount of nitrogen. You don't have to worry about the units here. And this is just for the benefits of farmers, to show them that if the farmer was interested in planting a wide buffer, say 5 meters on either side of the stream, as opposed to a narrow buffer, there would be more leaves that would be contributed to the stream, and of course, therefore, more nitrogen. And it's very important to note that this nitrogen occurs as organic nitrogen, which is very, very useful and important to an agricultural stream, as opposed to inorganic nitrogen, such as ammonium and nitrate fertilizers, which generally has a deleterious effect on it. This is some graphs of nitrate. Nitrate is a nasty chemical that shows up in groundwater. And in this slide here, we're looking at a natural forest that was on a part of Washington Creek that had not been agriculturalized. This is about 50 meters into the forest, 25 meters into the forest, and right at the stream edge. So you can see how the natural forest doesn't have much nitrate in its groundwater. That's because the trees are busily taking it up. And here it is in an agricultural situation. So nitrate ground levels in the agricultural crop are huge, but about 10 or 15 years after planting those trees, they are starting to utilize some of that nitrogen and starting to mimic the forest system in terms of what they're doing. So that was kind of interesting. So let's go up and take a look at Scott Lake in Algonquin Park. Now, this lake would be reminiscent or fairly similar to many of the lakes in Haliburton County. For those of you who don't know, this is Swan Lake over here. This is Scott Lake. This is Highway 60. And this part of Algonquin Park is about 300 feet higher in elevation than we are here in Haliburton County. So for those of you who know the park, here's Highway 60. Here's the Tea Lake Bridge. This is Smoke Creek. This is Smoke Lake over here. This is Swan Lake, where there was a forest research station for many years, and this is Scott Lake up here. So because of the elevation, you can see around the edge of the lake, there's a very cold ecoclimate, and so it supports a coniferous forest. And as soon as you move up higher into these very topographic hills, if you will, there's a very vibrant forest of maple and beech, but you can see this pattern repeated around many different lakes. So you may not be able to read all of the small stuff in the legend here. Suffice to say that this was a one lake study that has some inherent drawbacks to it, but there were very, very many parameters that were studied at this lake, including weather, soils, survey of wetlands, a variety of insect studies, which I'll talk about in a minute, study on coarse woody debris, which is such an important ecological parameter, bird counts, et cetera, et cetera. And I don't have time to talk about all of these tonight, but it was a very intensively studied lake. Again, it is a one lake system. Statisticians generally don't like that. They prefer you to have more lakes to study, but of course, expense is always a problem. So this research was funded under that provincial long-term ecological research program, which was short-lived back in the 90s. And as I indicated, one of the main frameworks of that document basically was the investigation of aquatic and terrestrial systems and their interaction. And there has been considerable data that has been collected over many, many years, which is nicely illustrated by this slide. So again, you don't have to know what the numbers mean along here. They're just indices of oak and rock bass growth. So for the oak trees, it would be probably the width of the annual ring that is produced by the tree. For the rock bass, it would be the growth of the scale on the fish, which is, as you probably know, how they can actually age fish. So this is from 1938 to 1952, and you can see how regional climate affects the growth of both terrestrial and aquatic environments. So we've known for a long time that these systems have been interacting. The problem is, of course, that if you're an ecologist, it's much easier to work in a terrestrial system or an aquatic system because they are much simpler than the complex mixture, which is the ecotone. So we're definitely lacking a lot of information on how these two systems interact. And this was our attempt in Algonquin Park, basically to take a look at some of this stuff. So one thing that I think many people aren't aware of, especially politicians who are involved in designing and developing guidelines for how shorelines should be managed, is how variable, even within one lake, the shoreline can be. So here's a picture of Scott Lake. You can see all sorts of medium woody debris here. You can see all sorts of coarse woody debris that is accumulated in this shallow bay. On that same lake, there was steep rock interfaces where you could actually dive down 15 feet if you jumped off this rock, and other bays in which other types of material accumulated. So in this case, the results of coniferous litter fall, you can see all the pine needles that have gathered into this bay, and they're going to be playing a very important ecological role for the next 1 or 2 years as they slowly decompose and provide food for a variety of different insects and other organisms. So we found just in this one very small lake, Scott Lake, it is an oligotrophic lake, which means it's nutrient poor. It's highly dependent upon whatever the terrestrial system surrounding it gives to the lake for its productivity. But it was very variable, and we really didn't know how to approach this. And so we had to stop. And we spent an entire year basically looking at all of the associated vegetation surrounding the lake, trees, saplings, shrubs, understory plants, mosses. Same thing in the aquatic system, all of the aquatic vegetation that was growing there, the slope of the bed of the lake, how much coarse woody debris was accumulated, et cetera, et cetera. We combined it all, threw it into a big fancy statistical program, and basically that allowed us to divide the lake into 4 fairly similar units. And so along this shore, for example, there's a big drumlinoid feature here, which is comprised of maple and beech, and the shoreline is very homogeneous along this area. But there turned out to be 4 different major types of landscapes associated with this very small lake. And so if you think about some of the lakes in Halliburton County, there would be much more than 4 associated with it. So I'll describe to you some of the very complicated equipment we use to monitor certain things. This is a Javix jug sitting on a piece of styrofoam tied in by a couple of pieces of 2x4. It's floating out in the middle of the lake, and it's essentially monitoring rainfall precipitation into the jug. It's emptied by students once every couple of days, or in the events of rainstorms more often than that. And so we could calculate the amount of water that was being input to the lake from rainfall. More importantly, we could take this back to the lab in Guelph and analyze it for a suite of different types of nutrients. Not all precipitation incident on the lake actually falls unfettered into the lake. Some of it strikes trees that have branches growing out over tops of the lakes. And so it's resident there for a while. It picks up a little bit of potassium, a little bit of nitrate. So it's enriched precipitation. And so this is a piece of an eaves trough, basically, on a couple of 2x2 stakes draining into a barrel right here. So we're actually documenting the amount of enhanced precipitation that is being added to the lake. These are groundwater lysimeters right here. And basically they're measuring the amount of nutrient content that is being input into the lake from the terrestrial component. from the forest itself. So water that's incident on the forest that might take a month to percolate through the ecotone and finally end up in the lake. And of course, these are our litter fall traps. Again, that pesky and very boring process that every ecologist needs to measure. These are just styrofoam platforms. These little indexes here, indents are allowed to allow precipitation to go out. And of course, the litter falls into the traps and then is collected on a regular basis in the fall season. And we take that back to Guelph and analyze it for nutrients and mass. In fact, here's your first data slide from Scott Lake. This is just amount of inputs. You don't have to know what the numbers are. This is when litter fall starts to fall out of trees, middle of September through to October. And then this is distance from the shore. So you'll see that most of it is falling fairly close to the shore, but a certain percentage of it actually ends up falling, up to 8 and 10 meters away from the shore, where the leaves will float down and play a very important role for a long period of time. So these are some of the students that worked on this particular project. They're all off happily employed now. And this was the culmination of about 4 years of those types of measurements. This is what we refer to as a stylized nutrient cycle. This one is for nitrogen. So it shows how much nitrogen, here's the units we use, grams of nitrogen per meter squared per year. That's incident on the lake, what comes down in the through fall or the precipitation that's incident on trees that are going next to the lake, what the trees actually contribute in litter fall, a couple of very important processes in the nitrogen cycle that actually decompose leaves and release nitrogen into the lake. There's another process whereby nitrogen is turned back into gas as denitrification, and of course, deep groundwater things. So I'm a big fan of the nutrient cycle and the nitrogen cycle, and there is no better way to judge the impact of shoreline development, removal of coarse woody debris, cottage development, etc., than having one of these things in your back pocket. Because once you have this for a lake in your geographical region, for an undisturbed lake, you can do the same thing on a lake that has cottages, very rapidly see what the impact is of cottage development or other types of development. Then you can, if you want, get into the politics and see if you can perhaps save some of these components of the nitrogen cycle to improve your lake quality, because it certainly, with cottages on it, has been denigrated from what it was 5,000 or 6,000 years ago when nobody was living up here. I'll say a little bit about woody debris, mostly because woody debris is stuff that people don't like, and I get it. I don't like swimming on shorelines that have a bunch of pieces of slimy wood there, but the slime that's on the wood is more correctly known as biofilm or periphyton. It's comprised of algae, fungi, bacteria, a bunch of complex organic compounds, and it's a very, very important food source for invertebrates and on up the food chain for fish as well too. And of course, that's the first thing that people like to remove from their cottage front. So we had some variety of different types of studies looking at the occurrence of biofilm on the woody debris that was in the lake. So woody debris can be fine, very small, be medium-sized, up to about 10 centimeters in size. You'll see here some of our litter fall traps, and then you'll see here a bunch of logs that have fallen into the lake. And this is what's known as coarse woody debris. In this particular case, we were able to estimate that this debris is resident in the lake for a minimum of 700 years, more likely close to 1,000 or a millennium. And it's because that coarse woody debris is there for so long that it plays a vital environmental and ecological role in the health of the lake. So as a physical barrier, it prevents certain types of, let me get at. Here, prevents or provides habitat for fish to hide from predators that are moving up and down the shore. But over that entire time, in that anaerobic environment, the wood is very slowly decomposing. And of course, what decomposes first is the early wood. That's the big part of the ring. And what decomposes last is the late wood. And through that entire time, chemicals are slowly leaking out of these big log bowls here. And if you will, you can imagine that the shoreline of lakes like this that are undisturbed by cottages are essentially a chemical cauldron. Here's a picture of, I'll come back to that in a minute. Here's a picture of Richard Guyette from the University of Missouri, and he's coring a living hemlock tree on the shore of Scott Lake. I apologize for this slide here. Coarse should be C-O-A-R-S-E, spelled wrong. And so what we have here is the ring width of these hemlock trees, living hemlock trees, measured from 1720 up in this case to about 1900. And then this is an increment core from one of the pieces of coarse woody debris that was in the lake. And you'll see how he's been able to match them up here. And so this is how we're able to basically determine how long a tree, or when it died basically and stopped producing rings, and therefore how many years it's been in the water. In this particular case, this tree here was only in the water about 125 years, but other ones that he looked at were, as I said, 700 to 1100 years. It's important to think about migrations of woody debris as well. It doesn't just fall into a bay in a lake and sink to the bottom and stay there. So this is a study we did with pieces of medium woody debris up to about 11 centimeters in diameter. So we took pieces of wood and painted them and then just let them go for a summer to find out where they ended up. Here's a small wind protected lake that never had any whitecaps on it or not. And you can see how woody debris moved all around the lake. So woody debris that is produced at one particular point in the lake can actually have a very important ecological role down the road in another part of the lake. And those same wind patterns would also move things around, such as pollen, which I'm sure you've seen on the shores of lake. Pollen is produced by trees and other plants. It's got a very tough skin, exene, and it stays around for a long, long period of time. And as a result, this is why paleoecologists and botanists are able to go into a swamp, core down and tell you exactly what was living there 10,000 years ago. But the very rich nitrogen content of it most likely does not stay around for 10,000 years. So these episodic events that occur sometimes depending upon the tree species, every year, every 2 years, every 4 years, every 11 years, are a very important source of nitrogen to lakes, especially lakes that are oligotrophic in nature and don't have a high degree of nutrients. A long-term ecological research program that goes for decades would capture events that occur on a very episodic basis. In fact, there's a very famous study ongoing in Washington State right now, where large Douglas fir trees, like 3 or 4 feet in diameter, have been documented on the floor of the ground. One university professor or one scientist is responsible for the study for the first 25 or 30 years. He or she retires and is replaced by another one. And it's expected that these logs are going to take about 3,000 to 4,000 years to decompose. Unfortunately, we didn't have a long-term ecological research program, but we did find an example of a tree that wasn't expecting to die, fell into the lake with its current foliage on, which was loaded in nitrogen, and just below the surface you can see all the algal that has loomed up as a result of this instantaneous input of nitrogen. And then that begs the question, episodic events into shallow versus deep waters, that's going to change the nature of the chemical cauldron that I was speaking to you about. And that ultimately is going to affect all sorts of things up the food line. I can demonstrate that by a very simple experiment that one of my students conducted. So they took 4 aquarium, and in one they put nothing, and in another they put pieces of maple, and in another pieces of cedar, pieces of hemlock trees, and then they just measured electrical conductivity. So the more solutes that are released from the tree, the higher your electrical conductivity is. So maple is a tree species that decomposes relatively fastly. You might find that hard to believe, but cedar and hemlock, cedar trees have been used for years by farmers because they make great fence posts and last forever. Lots of them on Duck Lake Road where I live. And of course, hemlock trees are still holding up part of the Toronto subway system because they're very decay resistant as well. And so you can see that depending upon the mix of branches that you would have from maple, hemlock, cedar, beech, poplar, oak trees, you're going to get a different chemical cauldron occurring in the near shore zone. I can use an example from a scientist I've never met. I can't remember his name, so I can't even give him credit. Daphnia are zooplankton. That's what they look like. They're pretty simple animals, if you will. You see this thing up here? This is what's known as their helmet. And they're capable of growing these helmets, which is a good way to identify them. This guy did a very simple experiment. So across the x-axis here, we have the instar of the Daphnia. So each stage, the bug gets bigger and bigger. And this is their helmet length. And he took 2 aquariums. He had one aquarium in which he had just water. And in the second aquarium, he put a fish in there, one fish for 1 week. Then he took the fish out. And then he threw some Daphnia in there, and this is what happened. So the Daphnia that grew where there was no fish basically didn't really change their helmet length at all. The ones that grew where the fish had been for just a week started to develop elongated helmets. And this was in a response to chemicals that are produced by the fish called caramones. And basically, when Daphnias sense fish, they produce a helmet on their head so that it's more difficult for the fish to swallow them. Who knew they'd be thinking about stuff like that? But once again, it just shows you how chemically structured and important the near shore zone is. And everything you do in terms of removing woody debris and removing litter and all the things you don't like when you're swimming are going to be impacting that. These are mayfly instars. And so I had a student who took packs of maple leaves, beech leaves, and mixed leaves and set them out in the water for a year. And then at the end of the year and through the course of the year too, looked at the mean number of invertebrates that were existing in each leaf pack. And so what you can see here is beech leaves seem to have the most number of invertebrates. These were the ones that were mixed, maple and beech, and then these were the maple leaves. A period of kill during the overwinter ice period, but the populations recovered a little bit. And when you look into the water, what you actually see are beech leaves that are still recognizable after a year of being submerged, whereas maple leaves have largely disappeared. So the mayflies have figured this out and know that it's a better place to build a house because the house is going to be around for a long period of time if you build it in a beech leaf as opposed to a maple leaf. And here's another student, Kelly Bowen, who did the same type of study, but this time she looked at taking medium woody debris and injecting it, putting it into the lake. So here's her pieces of maple, beech, and sorry, I think it was cedar, maple, and hemlock replicates tied onto bricks and then distributed into the near shore zone, the littoral zone. And she had 2 lakes she was working on. You can just look at Scott Lake right here. So the blue is cedar, the red is hemlock, the orange is maple, and you can see as they develop the density, number of organisms, this would be multiple genera per meter squared. You can see how it changed as the season went on. But what's interesting here is that cedar and hemlock, the 2 species which are known not to be infested by organisms that destroy them and have some protective properties, actually had more organisms growing on them than maple. And if you think just entirely about the chemistry, it doesn't make any sense. But when you examine the physical nature of them, it makes all sorts of sense. So because of course cedar and hemlock have a very rough ridged bark, nice little crevices for insects to get in there and colonize. And of course, maple at that age maybe 10 or 15 years old, has a very, very smooth bark still. And so there's less place for the insects to accumulate. So just before we leave Central Ontario, I'll just say a few words about vernal pools. I won't say an awful lot about them, but we did conduct a study up at the Frost Center. Master's student named Kirsten Otis investigated the decomposition in vernal pools and adjacent uplands on 28 different vernal pools, some large, some small, over a 2-year period, because these are vernal pools have been known for some time to be hotspots of carbon cycling, and in fact, that's what her study did determine. Very, very important for the decomposition and release of nutrients and other materials, and quite concerning in the face of climate change, where climate change is elevating temperatures, and so springs are shorter and vernal pools aren't sticking around on the landscape as long as they used to. So this has implications not only for decomposition processes, but for the life cycle of all sorts of things that start to produce eggs and start the early parts of their life cycle in there. So let's zoom up to the Esker Lakes research area. There's not an official area known as Esker Lakes. We at the University of Guelph named it because the series of 18 lakes is located alongside this esker. It's about 100 kilometers north of Cochrane. There was finally, after year 2 of the study, road access into the most southerly portions of the lakes. We had to travel by canoe and portage to all of the other lakes. We essentially did the same types of studies that we did down at Scott Lake in Central Ontario. This was definitely more of a boreal influence. For those of you who know the old folk song, the Blackfly Song by Wade Hemsworth, which was made famous by the Travelers, there's a line in there where it says something about survey to the west, survey to the east, had to find a way to make the little Abitibi turn around and go the other way. I never knew what that line meant until we were in an airplane, a helicopter, looking for this research site. And all of a sudden we flew over the little Abitibi River, and there you could see the diversion dam, and then a 4-mile channel where all of the water of the little Abitibi River is diverted and dumped into the big Abitibi River, so there'd be enough water to turn a turbine on a hydro thing. And it's clear as bell. So anyway, this research site here is not too far away from where that what I thought was a fictional folk song took place, but it apparently was a very real event. Pretty harsh environment to work for those of you who've worked up in the boreal forest. This is actually in early October, and this is us. This canoe here is going ahead, and the guy in the front has an axe and is cutting his way through the ice so that the student researchers can follow along. This is Lake 1 of 18 more to go. There was a portage in there that was almost a mile long, and so all the equipment had to be carried, canoes, paddles, everything, lunches had to be carried over, and litter fall collected and bagged and labeled and brought back. So it was a very difficult and trying project. And this project was funded under a federal initiative, but was of quite a bit of interest to Ontario authorities. So typically in the boreal forest, our forest management activities have said that you must leave a buffer along streams and around lakes and ponds. This has led to, if you fly over the area, a landscape that looks like what we refer to as donuts and ribbons. But if you examine the impacts of forest fires don't obey those rules at all. Sometimes they burn right down to a lake. They leave parts of the lake unburned. Sometimes they take out entire islands. Other times they leave peninsulas unburned. So the thinking has been in the last 10 years, maybe we should be designing forest management systems that would more naturally mimic some of the things that forest fires do to the landscape. And so now in what are known as the stand site guidelines, there are actually provisions where timber harvesting companies are allowed to harvest right down to the shores of the lakes. The long-term ecological consequences of this are not yet known. I don't believe anybody is studying, but for sure, harvesting is not the same thing as a fire. But anyway, as part of part of this. We had 13 lakes. They all had different percentages of their basins harvest. This was Lake 12, which only had 13% of its basin harvest. And this is when harvest occurred in all of these 3 months. This is June, this is July, this is August. And so this is dissolved organic carbon parts per million that is in the groundwater seeping into the lake. So even on a harvest that only harvested 13% of the lake's basin, you can see a dramatic input in the amount of carbon that is being exported from the harvested area to the lake. This was Paul Hazlitt's PhD work. So a lot of unknown questions about this still remain. So let's finally here come to the end. Just head up to the Northwest Territories, great place to work. And I had the opportunity on several occasions to do some projects up there. This guy here is Pete Cott. He was my master student. This guy is Paul Sibley, a close colleague of mine. We did a lot of work together. And he's now the director of the School of Environmental Sciences at the University of Guelph. Obviously had some benefits. This is a nice 4-pound lake trout I pulled out of a lake. The fishing up there is just absolutely incredible. I mean, you don't even have to think about it. So, so Pete Cott, my master student, this guy right here, this is a kind of an interesting story, and I'll take a minute sidebar just to say it. So there's a knock on my door at my office at the University of Guelph. There's this kid standing there. He said that his guidance counselor in high school said he'd never amount to anything. Excuse me. So he instructed him to go into a trades program. So the guy liked fishing and hunting. So he went to Sir Sanford Fleming and enrolled in the fishing game program. He liked it so much after 2 years, he opted to stay in for another 3rd year. He still wasn't tired of learning. So he came to the University of Guelph. He got the University of Guelph to bundle all of his 3 years of Fleming together and give him credit for 2 years of undergraduate at Guelph. And he was in his 3rd year, finishing up a general degree in his undergraduate program. And he came to me with this project. Just before I describe the project to you, let me tell you that I took him under my wing. He was a great master student, completed a great master's, went on to do his PhD on ling ecology. Ling is a very interesting fish. I think there's some in Helena County here, at Laurentian University, and now he's a senior scientist with the government of the Northwest Territories. So don't let anybody tell you that you can't advance, especially at the high school level. Anyway, he came across a very interesting scenario. Tibbetts Lake was just to the north east of Yellowknife. Half the lake had been burned by a fire. So these 3 sites, B1, B2, B3 are burned sites. These are unburned sites. For those of you who know about statistics, this is again a 1 lake study and what we refer to as a pseudo-replicated study. It was difficult to publish, but it finally did end up in press. And as he was walking around doing some survey for his boss, he was just noticing things about fish populations in the burned area compared to the unburned area. And so this is what the burned area looked like. It was very hot fire, burned right down to the edge. According to observers, some of the water was actually steaming and boiling along the edge. Some hunters and fishermen who had left their boat up there lost their aluminum boat because it was so hot, basically. And so what Pete did was he went out and he sampled in the nearshore zone in both the unburned and the burned area for young of year pike, which is what you see on your screen here. So he did the study in 1999. We submitted it to some scientific journals, a lot of them, and they kept saying you need more data. So he went back again in 2001 and found exactly the same thing. So that in the burned area, the young of the year pike were much smaller than they were in the unburned area. And so the thinking behind this was that in the burned area, a lot of the vegetation close to the shore was destroyed. Adult pike are cannibalistic on their own young. So they're always up in the weeds, basically looking for anything to eat. And so in the burned situation, it was only the very smallest young of the year pike that could actually get away from these guys. In the unburned area, there was more places for the fish to hide. And so the fish was more popular, the young of year were more populous and able to survive the onslaught of their parents, God forbid. And of course, these young of the year pike, if they survive, turn into monsters like this. This is Dr. Sibley. This photograph was taken exactly at 12 midnight on June the 20th, 2001, I believe. There's a nice pike for you right there. So just finish up on this last little study here. So if you've been to the Northwest Territories, you'll know that 40% of the roads are ice roads. If you've stooped low enough to watch whatever that show is about ice road truckers or whatever, you probably have seen some glimpses of them. They're only in existence for a part of the winter, and that's when they get all the supplies into the mines. They're really fun to drive because you can see somebody coming like 10 miles away. And so therefore you can be going like 160 kilometers an hour. If you want a real spin, just throw your car or your truck into a spin and you'll end up spinning for about half a mile or so, screaming your head off. When you stop, you can get out and look down at the ice. It's crystal blue and probably be about 10 or 12 feet thick. Climate change is going to have something to say about that. So where does the ice roads come from? Well, it comes from companies like this that suck the water out of small lakes. And the thinking here was, we don't know whether this is sustainable or not. Of course, the Canada Fisheries Act is the most powerful piece of legislation in the country. Thou shalt not kill fish. And so if any of these trucks were taking out water that was killing fish, they were going to be charged. So we got involved with this because many of these small lakes were totally drained of water with very little water left. So we found, again, I tend to like working with systems that aren't statistically strong. So we have one lake, which we call Lake 34, from which we took no water. Second lake, Lake 17. These were all fairly close to Yellowknife, which we took out 10% of the water volume of the lake. That's 32,000 cubic meters. And Lake 3, which we took out 20% of it, that was 77,000 cubic meters of water. How did we do that? With a very powerful pump, barrels of diesel that were flown in to get the water out of the lake that had 20% drawdown. Took us 3 weeks, 24/7, the pump running full blast, people sleeping in it and waking up when the fuel was low, pouring it into the tank, et cetera, et cetera. And we had to have the exit pipe had to go over the hill out of the watershed so that the water didn't flow back down into the site. So there's the tents at work here. You probably can't read the number on the meter there, but it's at 900 gallons per minute that we were removing from the lake. He looked at a variety of different responses to doing this, including number of fish and things like that. I'll just talk about one very briefly today. Changes to dissolved oxygen levels, which are very important. Oxygenated water that is suitable for fish to live in contains about 4% of oxygen. And so with no water withdrawal, oxygenated water existed to a depth of about 5 meters, although some very shallow lakes that would have been, would not have had any water taken out of them would have very little oxygen. At 10% withdrawal, that depth of oxygenated water dropped to 3, and at 20% to 2. So all the fish were basically forced to live in that 2-meter section. So there's now a policy in place that companies are allowed to take out up to 10%. That seems to have been the good thing to do in terms of fish populations. So that's about it for me on this talk. Understanding the linkages between aquatic and terrestrial systems is really necessary. There's not enough research going on. It's really exciting. It's fun. It doesn't necessarily have to involve lakes or rivers, but can also involve vernal pools. It's really important to understand that the common thinking is that terrestrial systems have something and they give it to aquatic systems. But in actual fact, it's a two-way exchange. So you have animals like lynx and mink that fish out of the water, raccoons as well, salamanders that breed and live in the water, but then move to the land. And the most classic example I can give you is what's known as the salmon forest. So coastal rainforest of BC, you may have heard about this. Bears spend a lot of time basically hunting for salmon. And there's about, on average, in most of the rivers over there, about 4 tons per hectare of salmon biomass is deposited in the forest by bears, which contributes up to about 20% of the nitrogen taken up by trees. And so bears hunt for these things, but then of course they forget where they put them. So they overfish, and then they eat a lot. They can eat about 4 times their weight of salmon. And after they're satiated, in this particular study, there's 6 to 7 tons of salmon left on the forest floor over a 2-kilometer stretch. So the interactions go both ways, from aquatic to terrestrial and terrestrial to aquatic. I'll end with this slide here. Since you're all muted, you can't answer the question that I'm going to ask. It's local. So I'm just wondering if you know where this is, and I can hear all your answers. And I don't know if you can see that or not. It's the Sawyer's Kashega-Wigamog Narrows on Highway 21, right by the marina there. And what I want to point out to you, you can see this a lot better in the wintertime as in the summertime, all the cottage and housing developments over here. Now, if you're in the audience and happen to own one of these, I am making no quality judgment on anything that you've done to your lot. I understand that you don't want to swim with slimy tree trunks, et cetera, et cetera. All I am saying is that this level of activity is going to make this lake here a little bit different than some of the ones that I've been describing to you over the last 40 minutes or so. And so a really good place to start is to find undeveloped lakes in Haliburton County, conduct some of the studies that we have conducted on them in the past, get yourself a good nitrogen cycle, find out what's going on in as pristine a lake as you can, and then you'll be able to do the same thing on lakes like this and look at what the impact of home and cottage development is going to be. And at that point, and probably at that point only you can enter the political foray and start to make some intelligent decisions about what or what not should be included in the shoreline bylaw. So I'm happy to be open for questions. I realize I've gone about 50 minutes here. Anybody has anything to add? I will.
What you could do for us right now is, is just to stop sharing your screen, and so that we can ask everybody to keep themselves muted. There's a couple of questions that have come through, and we can see, everyone can turn on their video if they choose to. Switch to gallery mode, and we can just have a few questions if you're willing to stick around. So that'd be awesome. So
Sure.
First of all,
Absolutely.
I wanted to say thank you very much. As you can imagine, the people are saying very interesting and useful. Thank you very much. One person said the experiment on Daphnia, the zooplankton, was probably done by Norman Yan, Dr. Norman Yan. Who was one of our presenters before. I'm not too sure if that's true or not, but that I think Caroline is saying that she believes it was probably done by Dr. Norman Yan. So that's kind of interesting. There you go. One question there's put, are you still there?
Yep.
Oh, sorry.
Yeah,
oh, there you are. There you are. Yes, go ahead.
Yeah,
You're going to comment.
I'm not sure that particular study was done by Norman. I know that he did work on things like that. I believe this was a Finnish scientist, if I'm not mistaken, but I have lost the original reference, so I don't know who did it. It could very well be Norman. So.
Okay, great. Well, we have a question out there. So anyone that has questions, we just open you to keep yourselves muted, but feel free to use the chat function to send the questions, and we'll just take them that way. One of the questions, could you mention the WWEW program that ULinks is undertaking and how it relates to this work? And I think we got to explain what the WWEW program is first before we answer that question. So just feel free to answer that one, Andy.
Sure. Okay, so I'm assuming most everybody knows what ULinks is. It's been around for about 30 years, 20 years as ULinks. We basically broker research. Am I muted? No.
No, you're doing well. I was going to explain to them what ULinks is, and their office is in Minden. I think it's important just to just explain.
Okay, so we broker research between businesses or environmental organizations in Haliburton County and students and faculty at Trent and Fleming. In 2019, we launched what's known as the Woodlands and Waterways Eco Watch program, and it's been very successful so far. We've started a program of benthic biomonitoring. Benthic organisms are like some of the ones that I was describing there. They're generally good harbingers of good water quality. We've collected about 3 years of data. We're up to about 25 lakes, and we're in the process of starting to analyze it. Coincidentally, alongside that, we're about to launch a pilot water quality testing program on about 10 lakes with the support of a number of partners. And I'm pretty sure that that's going to be successful as well too. And we'll be ramping that up in the coming years. And the entire purpose of both of those two programs is basically to ensure the continued health and integrity, ecological and otherwise, of the lakes in Haliburton County. We're one of the few counties that doesn't actually have a conservation authority, which would normally be doing some of this type of research and monitoring. And ULinks has decided to take the lead in doing this, along with a variety of partners, including many of the lake associations that are probably represented by the individuals here.
Beautiful, thank you. Another question is, what needs to be done to encourage folks to allow trees to fall into the lake? And could folks just move woody debris to one side away from their swimming area? Would that help this dilemma? I
think just public awareness of the important role that coarse woody debris, medium woody debris plays. So my in-laws, for example, have a 14-acre property on Spruce Lake, quite a bit of frontage. It is a drawdown lake, as most other lakes are in the area too, and there's not much they can do about that. They have a small area that has a dock and where the boats go, and the rest of their shoreline is pretty much intact and does have coarse woody debris. And I understand, like I said in the presentation, I absolutely get it. I mean, I don't like swimming on slime logs either. But the more we understand about the important ecological role that this stuff can play, we can actually start to design and develop management systems that would allow the reintroduction of some of this material on a portion of an individual's property. It's the same thing I was saying about the vernal pools. Climate change is acting to remove vernal pools from the landscape, and is probably going to do it within the next 50 years. And that's going to be a major, major loss to the ecological integrity of the forest around here. So we need to be starting out to think about designing management systems that would allow partially cut types of scenarios around the edges of vernal pools, that would allow snow to accumulate on certain sides of vernal pools, so that when it melts in the spring, it would actually refurbish and replenish the vernal pool. So there's, in many cases of things we've been talking about, there are technological solutions out there based on science, and it's more important probably to be talking to individuals who have cottage and home waterfront situations about some of the things that they can be doing to enhance and preserve the integrity of the nearshore zone.
Interesting. Thank you. There's another question along the similar thing. I've been trying to plant trees and plants along the shoreline to restore it, but the deer have been eating almost everything. Are deer a new problem?
I wouldn't say deer are a new problem, but deer certainly like the most succulent plants they can get. You'll notice in tough, cold, hard winters, they'll go after the cedar branches along the shores of lake. That's not their preferred food. They'd be much happier munching on something that was more succulent. And unfortunately, newly planted trees fall into that particular category. So there are fairly cheap ways to protect trees using things such as tube shelters, even homemade designs where you can have 3 1x1 or 2x2 posts with a bunch of screen around them. It is a cost to the landowner for sure. Once the trees get to be a certain size and height, they become not as attractive to deer basically, and they'll be off in search of something else.
Interesting. Yeah. Because you can certainly see them enjoying the shoreline foliage there in the wintertime. So that's interesting. Another question is, do the companies that draw up the water, lake water, to spray on the ice roads, do they make any effort to not grab those fish as well? Use like a screen or on the uptake pipe or something?
Yeah, I'm sure there is. The impact on the fish is probably not the physical removal of the fish, but the actual decrease in the amount of oxygenated water that's available to the fish population. So it wouldn't surprise me that they all have screens on the end of their tubes, but at least until that study was conducted, there was no regulations at all. I mean, if you had a truck that could haul water, you could stop at any lake you wanted to and suck as much water out of it as you wanted and sell it to the companies that were making the ice road, basically.
Wow. Interesting. And kind of sad at the same time.
Yes.
Is there anybody else that has any questions out there for Andy? I mean, it's been quite informative and quite useful for us, especially in a very topical in the sense that we're all looking out for our shorelines and even seeing the places on Sawyer's Lake. There's places around that not the only people that are not just Sawyer's Lakes, other ones that need to worry about our shorelines. So it's very topical. Bob, were you going to say something? You unmuted yourself.
That was Kashega-Wigamog Lake, not Sawyer's. Not that I'm pointing the finger.
Oh, sorry. I thought you said Sawyer's. I thought it said Sawyer's. That was my. Sorry.
The Sawyer's, Kashega-Wigamog, the Narrows. Where
Oh,
the bridge
okay.
goes over.
Okay. I thought it was looking from the marina out into the Sawyer. So it's actually working that way. Wow. Okay.
That's right. Yeah.
So it's on Kashag. There you go. So my bad.
And Kirsten, I was just waiting for you at some point to toss
Oh,
it. So
well, no, I was just going to wait. Sorry, I thought you unmuted yourself. So I
No.
thought you wanted to continue the conversation. But yes, I just wanted to make sure there's no one out there that has any other burning questions. As Andy said at the early, feel free to email him at, I think it was director@ulinks.ca or something like that, Andy. Is
That's
your email
correct. On the front slides, my University of Guelph email, so they can certainly contact me there as well, whatever works. So
yes.
depends on the day which one I read. So
That's great. If you have any burning questions, feel free to send them that way or send them to us right now through the chat. Otherwise, I'm going to throw it over to Bob, and Bob's going to say thank you.
Well, thank you very much, Andy, for this talk today. I think it's, it just goes to show how complex and how complicated all of these systems are. I mean, if I take anything from what you have said today, is natural shorelines good, developed shorelines bad. So if that's my simplification, and I think that has to be the sort of the motto that we all have to live by if we want to keep these lakes in good shape, particularly with the challenge of climate change that is around. I do want to, full disclosure, as people know, I'm a counselor for Minden, and Minden is closely associated with ULinks and was one of the original founders of ULinks, and I am the representative on the board from the Minden Hills. But I would encourage all of you to go to the ULinks website and the WWEW website, because there's some very, very important work that is being done there. And it not only is a benefit to our local community, but it's also a benefit to all of the students, some of whom are local students who are attending Trent and Fleming, and it gives them an opportunity to get out of the classroom and do actual work in the field and really understand what's going on out there. So once again, Andy, thank you. I have the virtual envelope that I will pass over to you with the official thank you, and which will be followed up by Canada Post, I think, in the near future, if I'm not mistaken, Jan. I just wanted to also mention to everybody that June 15th is the annual general meeting for the LKO. It's at 7 p.m. and will be held by Zoom. So we look forward to seeing you all there. It tends to be a very action-packed event. So come early and be prepared to be wowed. And I think with that, we sort of end our evening.
Yeah, so thank you again, Andy, and thank you, everybody. Andy was very informative. Thank you, everybody. Thank you, everyone that made these Love Your Lake seminars. This is the end of our finale for this year, but we'll start some more next year. And anyone that has any interest about topics or knows someone, that feel free to send that to us, and we can sort of include that in our next planning session. So thank you, everyone, for being here, and have a lovely rest of your evening.
Thank you for the invite.
Thank you.
I really enjoyed it.
Thank you so much, Andy.
Thank you.